Good morning, scholars. Let's review for your test. All right. First thing that'll be on your test are equations of parallel and perpendicular lines. Equations of parallel and perpendicular lines. So what do you know about, let's start with the parallel lines. Sure. Yeah, what do you know about parallel lines? Well, they look like the same line, but just shifted over. So parallel lines never cross. You've been knowing that for a minute. And also, they have the same slope. Same slope. Perpendicular lines, on the other hand, perpendicular lines definitely cross. They cross in a very specific way. They cross at a right angle. And they have opposite reciprocal slopes. Opposite reciprocal slopes. So for example, if I had a line with a slope of 1/3, the perpendicular slope would be opposite, meaning this one's positive, so my new one's going to be negative. And reciprocal, meaning I flip the numerator and the denominator, so -3/1 or just -3. Those are your parallel and perpendicular line slopes that you'll definitely need to know for tomorrow. We also need to know something a little bit about equations of lines. You can have equations of lines in slope-intercept form, y equals mx plus b, or point slope form, y minus y1 equals m times quantity x minus x1. Let's look at both of these. Y equals m times x plus b. Y equals mx plus b. What's that m stand for? Of course, slope. And what's that b stand for? Of course, the y-intercept. Alright, so why is this called slope-intercept form? Because you have the slope and the y-intercept in the formula. Now how about the other one, the point slope form? Well, it still has that m, that still means slope. And x1, y1 is a point on the line. x1, y1 is a point on the line. Cool. So if you're given the slope, or you're given the line it's going to be parallel to or perpendicular to, you could find the slope really easily. If you're given that and you're given the y-intercept, go ahead and stick with the slope-intercept form. If you're given a point on the line, then use the point-slope form. So much easier. Alright, doing great. Okay, the rest of the stuff for your test is all about triangles. You need to be able to classify triangles by their sides and angles. So let's think about the classifications we have. We're talking about by their sides. We could have all the sides being equal, right? That's our equilateral triangle. We could have two sides that are equal. That's our isosceles triangle. Or we could have all three sides different. Call that scalene. Now if we think about classifications by angles, we could have let's see, all of the angles be exactly the same. That's called equiangular. Angular, just barely made it. Awesome. We could have all of the angles, they don't have to be equal, but they could all be acute. Or we could have one right angle, making it a right triangle. Or we could have one really big angle, call it obtuse. So every triangle has two names, one name that talks about its sides and one name that talks about its angles. If you ever have an equilateral triangle, it will be equiangular also. So these guys always go together. They always go together. Equilateral implies equiangular. Equiangular implies equilateral. All right. Speaking of triangles, we'll also be talking about the triangle sum theorems. Triangle sum theorems. I'm going to abbreviate it, THMS theorems. Well, what's sum mean in math? That means the solution to an addition problem. So we're going to be talking about adding things. So one of the cool things about triangles is it doesn't matter what they look like. Could have a skinny triangle, could have a really big wide triangle, could have a right triangle. Any type of triangle, if you take all of the angles and add them up, they will always add up to how much? 180 degrees. That's right, ladies and gentlemen. So the sum of the interior angles of any triangle is 180 degrees. Alright, let's get some more colors up in here. So, got my blue angle here. Got my green angle here. Got my orange. It's a weird color combo. It's all good. Okay. Add those three up. They're going to equal 180. They're going to equal 180. Same with any of these triangles. Adding all three angles of the inside of a triangle up, you're going to get 180. So we also have what's called exterior angles. So we think about a triangle and we extend one side of it pretty long. This right here is called an exterior angle. It's called angle 1. And then let's call this angle A, and this will be angle B. The measure of angle 1, this exterior angle here, the measure of angle 1 equals the measure of angle A plus the measure of angle B. So it's not the guy right next to it. Definitely not the guy that makes the linear pair. The measure of the exterior angle equals the sum of the non-adjacent angles A and B. Cool? Cool. Alright, so we had these equations of parallel and perpendicular lines. We had classifying triangles by their sides and angles. We just talked about what happens when you add up all of the angles inside a triangle and how you can find the measure of an exterior angle based on the two non-adjacent angles. So now let's talk about congruent triangles. Congruent triangles. Okay. Let's say I've got, I'll do my best here to draw some legit congruent triangles. I'm drawing not looking exactly the same. We actually have to use our brains here a little bit. Let's call this triangle A, B, C. This will be triangle D, E, F. Let's say AB is congruent to DF. BC is congruent to DE, and AC is congruent to EF, which would make angle A congruent to angle, okay, that's between the ones 1 hash mark and 3, so 1 and 3, A and F are congruent, B and D are congruent, and E and C are congruent. So our congruent statement here says, actually I want to write out what we just said about all those sides. We had AB congruent to DF. We had BC congruent to DE. We had AC congruent to EF. Awesome. And then we had angle A congruent to angle F. We had angle B congruent to angle D. And we had angle C congruent to angle E. So our congruent statement tells us which triangles are congruent. We've got triangle A, B, C congruent to, well, who was congruent to A? It was F. Who was congruent to B? It was D. Who was congruent to C? It was E. Right? We need to be able to do all of those things. Identify all of the congruent parts of two congruent triangles and say a congruent statement about those triangles. And finally, the most fun part of all the stuff that we've talked about is proving triangles congruent. All right, we talked about 4 ways to prove that triangles are congruent. Either you could have a side-side-side congruence. You could have side-angle-side congruence, angle-side-angle congruence, or angle-angle-side congruence. So this is in lieu of having to show that everything was congruent. Like we just did on that last problem. We showed that all 3 pairs of sides were congruent and all 3 pairs of angles are congruent. This allows us to show only that 3 things are congruent as opposed to 6 things. So it's saving you some time. All right, side-side-side congruence happens when you have all 3 pairs of sides of 2 triangles are congruent. Okay, that's side-side-side. Side-angle-side is when you know 2 pairs of sides are congruent and the angle between them is congruent. So that angle has to be between those 2 sides for this to be side-angle-side. Angle-side-angle is when we know 2 pairs of angles are congruent and the side between them is congruent. That's angle-side-angle. And then angle-angle-side, when you have 2 pairs of angles are congruent and a side that is not between them is congruent. Okay. That would be angle-angle-side. Cool. All right, I want to talk about a couple things that could be marked in diagrams that will not be marked in diagrams that you will have to know are true. So say, for example, you've got these 2 triangles. They're kissing up right next to each other. Let's call them A, B, C, D. And they tell you those 2 sides are congruent. And they tell you, let's say, these 2 sides are congruent. And you're like, yo, are these triangles congruent? And you're like, that's only 2 things. I definitely need 3 things. What else could be marked congruent? They share the side, man. It's the same thing. AC is congruent to itself. Got it? Yeah. Another thing that's going to show up is you're going to have 2 triangles that are something like this, maybe. They're formed by 2 lines crossing. Got it? And they'll say, you know, are these 2 triangles congruent? And you're like, I need a third thing. Ooh, the vertical angles right there. So yes, they're congruent by side, angle, side.